In this problem, I need to simplify this expression over here. As you can see, there are coefficients and variables in both the numerator and the denominator. So what I'm going to do to start with is I'm going to work on the numbers. And since this is a fraction, I'm just going to reduce the numbers as usual. So 2 goes into 2 once, 2 goes into 6 3 times. So I'm going to get left with 1 in the numerator and 3 in the denominator. So now I need to start working on my variables. And I'm going to need the quotient rule for exponents that says if I have a to the m in the numerator divided by the same base a to the n in the denominator, my answer is a to the m minus n in the numerator. And please notice that the exponent in the numerator is first, and then we subtract the exponent in the denominator. So that's exactly what I'm going to do with my two x's here. So I'm going to have the answer is going to be x in the numerator. I take the numerator exponent 2 and subtract the denominator exponent 5. Now let's repeat the process with the y's. So I'm going to have my answer of y's in the numerator, and then the exponent is going to be 3, because that's the exponent in the numerator, minus the exponent in the denominator, which is 2. So now all I need to do is simplify it. We don't ever write the 1, because 1 times anything is just the anything. So I'm going to get x raised to the 2 minus 5 is negative 3, and y raised to the 3 minus 2 is 1. So that's taking care of my numerator, and what do we get left with in the denominator? Don't forget the 3. So is this totally simplified? No, we cannot leave negative exponents in our answer. So looking at the rule for negative exponents, a to the negative n in the numerator becomes a to the positive n in the denominator. So in this problem, my x to the negative 3 in the numerator is going to become x to the positive 3, or x cubed in the denominator. Do we ever write an exponent of 1 on a variable? No, so that just becomes y, and then I need my 3 for the denominator. So can I simplify that anymore? No, my bases of y and x are different, can't combine them, so that is my final answer.